Okay, so we're going to talk about distance. Today our focus is going to be finding distance when we're on a number line. And tomorrow we're going to focus on finding distance or length of a line segment when we are working in the XY plane. The distance between 2 points is the length of the segment. So to find the length of a line segment, if I have 2 points, P and Q, and P has coordinate x1, Q has coordinate x2, then the way we find the length of the line segment is by doing x2, the absolute value of x2 minus x1, or the absolute value of x1 minus x2. So let's do a quick example here. So for example, let's pretend that point P has a coordinate on the number line of 3, and point Q has a coordinate on the number line of 7. Then if we do the absolute value of x2 minus x1, I would have the absolute value of 7 minus 3, which would give me the absolute value of 4. Or we could do the absolute value of 3 minus 7, which would give us the absolute value of -4. Have you guys ever seen absolute value before, these bars that I'm putting around these numbers? All right. Some people know, some people yes. So let's go through and explain what this is. The absolute value let me write that down. Absolute value makes numbers positive. So if I already have a positive number, the absolute value doesn't change it at all. So the absolute value of 4 is 4. If I have a negative number inside the absolute value bars, the absolute value is going to take that negative sign away. So the absolute value of -4 is also 4. It's going to take our value and make it positive. So if it's already a positive, we're just going to leave it alone. If we get a negative number, absolute value is going to change it and make it positive. All right. You guys ready to practice? All right, let's look at example number 1. Use the number line to find CF. Well, here's C, and over here is F. So C is at -1. We're going to call that our x1. And F is over here at 5, so we're going to call that our x2. So the distance or the length from C to F is equal to the absolute value of x2, which is 5, minus my x1. What is x1? -1. So I'm going to put that inside parentheses so that it doesn't get confused with my subtraction symbol. What happens when we subtract a negative number like this? Makes it positive. So this is the absolute value of 5 plus 1. What is 5 plus 1? 6. So this would be the absolute value of 6. And what is the absolute value of 6? 6. Perfect. So we could do it like that. Or, remember, it doesn't matter which order we put our x's in, our x1 and x2. I'm sorry, I'm right in your way. So let's try it the other way around. I could do -1 minus 5, switching my two numbers around. It still gets subtraction in between. What is -1 minus 5? -6. And what does absolute value do to negative numbers? Makes them positive. So I get 6, no matter whether I do it x2 minus x1 or x1 minus x2. I get the same answer either way. So CF is 6. All right, let's try that for part B here. Use the number line to find AE. Well, here's A, and over here is E. So we want this segment right here. So I'm going to let A be my x1, and I'm going to let E be my x2. So now the length from A to E is equal to the absolute value of x2, which is 7, minus, yes. The bars, they mean absolute value, and that's what changes our numbers to be positive. So we put that around our numbers until we get to the end because we want to see if the stuff inside is a positive number or a negative number. If the stuff inside is a positive number, then those absolute value bars just disappear. And if the stuff inside is a negative number, then those absolute value bars take the number and change it into a positive number. Yes? -5 plus 7. So when we're doing our distance on the number line, it's always subtraction in between our two numbers. The only time it changes to be adding is if I subtract a negative, but it always has subtraction to start with. And then if the second number ends up being a negative number, then it would change it into a plus. Great observation there. All right, so 7 minus, and then we have -5, my x1. So here's another situation where I see adding a negative number. So that's going to turn into what? Addition. So that's going to be 7 plus 5 inside the absolute value bars. What is 7 plus 5? 12. Yes. So we have the absolute value of 12. What would the absolute value of 12 be? 12. Perfect. So we can do it that direction, or remember, it doesn't matter if I switch my numbers around the other way. We could do AE is equal to, then I could have -5, my x1, minus 7, my x2. What is -5 minus 7? -12. And what does the absolute value do to the negative with that 12? Makes it positive. So I get 12 no matter which way I do this. So AE is 12. Beautiful. Yes? Is there a specific order you have to put the numbers in? For this one, no. It doesn't matter whether you do it this way or this way. The absolute value will take care of making sure that your number at the end is positive, and it should come out the same either way. So if you're concerned when you're doing this on the homework, if you're concerned that you might have done it wrong, you can flip the numbers around the other way and make sure that you get the same answer that way. If you get the same answer both ways, you did it right. All right. Let's look at number 2. We're going to determine some congruence here. Are these things the same size? So we want to determine whether segments CB and DF are congruent. Well, here's C and B. So I'm going to call B my x1, and I'm going to call C my x2. That's for segment BC, or CB. Then we also want to look at segment DF. So D is over here, and F is right here. So we're looking at this segment. So I'm going to need another X1 and X2 because I'm looking at a new segment. So I'm going to let D be my new X1 and F be my new X2. So for CB, we do the absolute value of X2 minus X1. So I have -1 minus my X1, which is -3. What happens here where we subtract a negative? Turns it into a positive. So that would be -1 plus 3. What is -1 plus 3? 2. I have the absolute value of 2. And what is the absolute value of 2? 2. So the length from C to B is 2. Now we need to find the other length from D to F. So we're going to do the absolute value of X2, which is 5, minus X1. X1 is 2, so I have 5 minus 2 inside my absolute value bars. What is 5 minus 2? 3, so I have the absolute value of 3. What is the absolute value of 3? 3. So I have one segment that's 2 and one segment that's 3. Are these segments congruent? No. Why not? What does congruent mean? That they're the same. They're the same size. Well, I have one segment that's 2 units long, one segment that's 3 units long. So I would say no. CB, with the dash over the top, is not congruent. So I draw the congruent symbol, the equal sign with the squiggle, and then I put a slash through it for not. And then DF. CB is not congruent to DF because 2 does not equal 3. So those two are not congruent because they did not come out to have the same measurement. If they did come out to have the same measurement, if it was 2 and 2 or 3 and 3, then I would say yes, they are congruent. All right, last problem. Determine whether AC and BD are congruent. So here's AC. A is at -5. C is at 1. I'm going to let A be my X1 and C be my X2. Let's go ahead and find that length first before we go look at our other segment. So from A to C, I get the absolute value of 1 minus, because it's always minus after my first number. And then what's my second number? -5. So I have 1 minus -5. The -5 goes inside parentheses. Remember, after the first number, it's always a minus. I'm subtracting a negative here, so what happens? Positive. So this really becomes 1 plus 5. 1 plus 5 gives me 6. And what is the absolute value of 6? 6. Perfect. So this segment is 6 units long. The other segment that we want to go look at is segment BD. Well, here's B at -1, and here's D at 4. So this segment right here. I'm going to let B be my X1, and I'm going to let D be my X2. So from B to D, We do x2 minus x1. So I have 4 minus what? 4 minus -1, yes. So once again, subtracting a negative turns it into a plus. So that would be 4 plus 1, which gives me the absolute value of 5. And what is the absolute value of 5? 5. Excuse me. 5. So are these two segments congruent? No. AC is not congruent to BD because 6 does not equal 5. That's where we are going to stop your notes. Yes. It can be x2 minus x1 or x1 minus x2. I'm just used to it the other way around. I'm used to always doing 2 minus 1. So that's the pattern that I tend to stick with, but you get the same answer if you do it the other way around. All right. Did you have a question?
Yeah, it's just like for the other. Sorry, it's just right here. When we're doing it like this, how come we can't do it like this?
We can. I just didn't have enough room to do it both ways there. I just ran out of paper, so I only did it one direction.
Okay.
All right. Please go ahead and clear your desks off. The new homework that you received is due on Monday, by the way. But go ahead and clear your desks off of everything except for a writing utensil for the quiz. When you are finished with your skills check, it goes here in this wire tray that is labeled as skills check. So you'll put that there, and then you can return to your seat. There are 3 questions total. They are all on the front side of the page. Remember, in every module, we will have 2 skills checks. Only 1 grade will stay in the grade book, though, only the highest grade. So if you don't do well on this skills check, you have the opportunity to replace this grade with a higher one next week. Good luck, everybody.